Hi guys, here we go, starting a new unit, our last unit for the year, circumference and arc length. This unit 11 is going to be dealing with circumference and arc length, your area of sectors, volume of your 3D figures like cones, cylinders, prisms, pyramids, spheres, things like that. So the first topic for this unit, circumference and arc length. Circumference is the distance around the circle. So it's kind of like perimeter, but perimeter we refer to with polygons. Since a circle isn't a polygon, we just say the distance around a circle and it's called the circumference, but it's the same idea. And our formulas for circumference, we can say pi times diameter. So your D stands for your diameter. Remember, your diameter is the guy going all the way across your circle. Or you can say 2 pi r, where r is going to be your radius, and we know that 2 radii going from center out, 2 radii is the same as 1 diameter. So that's where that comes from. All right, so let's start with an easy problem here. I want to find the circumference to the nearest tenth. For my first problem, they're giving me a radius, so I'm going to use the formula circumference is equal to 2 pi r. Circumference is equal to 2 pi times my radius, which is 14.3. Make sure you use the pi button in your calculator. And once you do that, you should get that the circumference is approximately 89.8. For the second guy, they're giving you your diameter going all the way across. So your circumference is going to be equal to, in this case, I'm going to say pi d. So circumference is equal to pi times diameter, which is 33. Into your calculator using that pi button, and you should get approximately 103.7. All right, so that's circumference. Pretty easy. We should know our circumference formula. The next is going to be arc length. This is going to be a portion of your circumference. Circumference, again, is the distance around your circle. The arc length is just going to be the distance going between 2 points here. And how do we do that? It's the portion of the entire guy. So in order to do that, I have to have a ratio. I'm going to take the length of this arc AB over the length of my entire circle. And what is that called? That would be my circumference. But I have to set that up to something else where I can use another ratio. That's going to be the arc measure over the entire circle, which is 360. So here is your formula to figure out your arc length. It's going to be the arc length over circumference, and that's going to equal to the arc measure over 360. This is kind of confusing, arc length and arc measure. Like, what's the difference between those two? So measure of arc versus your arc length. Well, let's look. If I have two circles, let's say I have this little guy right here, and I have this as a right angle, and I have this circle, and I have this guy as my right angle. Well, this is a central angle, and I know that the measure of my arc is going to be the exact same as the central angle, and the arc would be the exact same. So I know this guy's central angle, the measure of this arc is going to be 90 degrees. Well, that's how many degrees it is, how much it's opened, and altogether it's always going to be 360, no matter if you have a little tiny circle or if you have a big circle, you're always going to get 90 degrees there. Well, that's going to be your measure of the arc. But my arc length is different between these two. So yeah, they have the same measurement of both having 90, but if I look at this arc here, this curve, and I try to make it into a straight line, it would only be about that much. If I were to make this here into a straight line, it comes out like this. But if I look at this arc here, and I try to make him into a straight line, he would look something more like that, right? If I take this guy here and I try to make him into a straight line, I get that. This guy into a straight line looks like that. So you can see the measures are going to be the same. They're both going to be 90 degrees. It's a quarter of the circle, right? But the arc lengths are very different. If you take that part of the circle, make it into a straight line, this here is your arc length, and over here is the measure out of 360. So hopefully that clears it up between the difference between a measure versus the length. Okay, I want to find the length of AB here. So remembering my formula, I'm going to take the length of my arc AB over my entire circle, which is pi d. Remember, this is my circumference down here. And that's going to be equal to the measure of the arc over 360. So let's replace all the information that we know. We know that this bottom is always going to be 360 because it's always 360 total in my circle, degrees around. Now I want to know, what is the measure of this? And this is back from Unit 10. How do I figure out this measure? Well, it's going to be the exact same as the central arc that made it. Well, here is 150, so these two are linear pair, which means this has to be a 30 degrees. So if this is 30 degrees, that means the measure of this arc is also going to be 30 degrees. And then I'm asked to find the length of AB, which is this guy up here. That's what I don't know. That's what I'm looking for, the length of my arc AB. And then down here is my circumference of my circle. So I know that my diameter here is 34, so this is going to be 34 pi. Now I have to get my x by itself, so I'm going to cross multiply and cross multiply. So I'm going to get x times 360 is equal to, now going this way, I'm going to get 30 times 34 pi. And then just getting my x by itself, divide this side by 360, divide this side by 360. So x is equal to 30 times 34 pi divided by 360. Again, don't forget to use your pi button in your calculator. You plug this straight in, and so you get a value or a length of your arc to be approximately 8.9. Next one. In this case, I'm asked to find the measure of arc AB, not the length. I want the measure, which means this is going to be my unknown. I'm looking for that measure. So let's replace what it is that I know. Again, I know that this guy down here is going to be 360. This is what I'm looking for, the measure of arc AB. So this is going to be my x. And then I know what my length is. My length is 18.84. 18.84 inches. That's my length over my circumference. And so my circumference, I have a radius of 9, which means here I'm going to get 2 pi times 9. In other words, I can change this to be 18 pi. 2 times 9 is 18. So I'm just going to change this guy down here to be 18 pi. Because I just did 2 radii. And now I'm going to cross multiply to get my x by itself. So I get x times 18 pi. And that's equal to 360 times 18.84. Dividing both sides by 18 pi, I get x is equal to 360 times 18.84, all divided by 18 pi. So into your calculator, to the nearest degree, you get the measure of arc AB to approximately 120 degrees. And one more, we want to find the radius. Looking for the radius of the circle. So down here, this isn't my unknown, it's part of this. Instead of saying pi d, I'm going to say 2 pi r. And the reason why is my radius is the guy I want to find. He's what I want to get by himself. So let's replace what we know. And I know the length. The length of my arc is 1.57. The measure of my arc is 45 degrees over 360 degrees. And I'm looking for my radius. So I'm going to get 2 pi r. So that's my setup. Now I'm going to cross multiply. I need to figure out what my r is. So cross multiply here. I'm going to get 45 times 2 pi r. And that's equal to 360 times 1.57. And then dividing by, I want to keep my r by itself, so I'm going to divide by everything else, which is going to be 2 pi times 45. Well, 2 times 45 is the same thing as saying 90, so I'm going to divide by 90 pi. Again, this is the same thing. 2 times 45 is 90. So in your calculator, you're going to have r is equal to 360 times 1.57 divided by 90 pi. And you're going to get this, that your radius to be approximately 2 feet. All right, so you guys have a couple questions waiting for you in Go Formative. It will close tomorrow night. If you have any questions, go ahead and text me. Thanks, guys.